Okay, to start the third method of solving a system of equations, which is elimination, I actually want to start by just doing a review on solving a system of equations by substitution, which is what we did in lecture 13. So this is one that is actually a bugger to solve with substitution, so don't get too freaked out. I'm not going to give you anything like this for a homework problem, but I do want the steps to make sense. Even though this one has fractions along the way, there's no reason why it shouldn't make sense to do it with substitution. It's just not the smartest way to do it. So first of all, our first step for substitution is to find a variable that is hopefully easy to solve for. If we look at the four choices we have here, we have x in the first equation, which not only has a 4 in front of it, but not everything else in the equation is divisible by 4. Or I could have got the y in the first equation, but nothing else in that equation is divisible by 3. On the second equation, I've got a negative 4x, and again, one thing's divisible by 4, but not the 10. I've got 10y, and nothing in there is divisible by 10. So there's really not a good choice. We're just going to have to choose one and try to minimize our damage along the way. So let's just pick y in the first equation. At this point, it doesn't really matter. I'm just picking one so that I've got something to work with. 3y equals 4 minus 4x. I need to get y by itself. So I divide both sides by 3, and I get y is equal to 4/3 minus 4/3 x. It might not be pretty, but it should make sense. So look at that and make sure it's okay. Okay, so I've got one variable solved for. What do I do with that? Okay, I'll plug it in for y in place of y in the second equation. So I'll still have negative 4x plus 10, and instead of y, I'll write the 4/3 minus 4/3 x equals negative 4. So just compare what I have here, negative 4x plus 10 times a big set of parentheses equals negative 4, to the second equation up top. It's exactly the same thing, but instead of y, I've written what y is equal to. Okay, now my next step is to distribute that 10. Again, it's not going to be pretty, but we know how to do it. We think of 10 as being 10 over 1. 10 over 1 times 4/3 would be 40/3. 10 over 1 times negative 4/3 x would be negative 40/3 x. And then my negative 4x on the beginning and my negative 4 on the other side don't change at all. Okay, so I've distributed. Remember, the first step is to distribute. My next step is to combine like terms. Well, the like terms I have negative 4x and negative 40/3 x. Those both have an x. To combine those, I need a common denominator. So negative 4x would be negative 12/3 x. I'd multiply top and bottom by 3. And now I can combine those. So negative 12/3 x and negative 40/3 x would give me negative 52/3 x. I still have that plus 40/3 equals negative 4. Now I need all my numbers on the other side, so I subtract 40/3 from both sides. Again, I need a common denominator. Now that I've got a common denominator, I combine, and at last there is a little bit of a light at the end of the tunnel. If I have negative 52/3 x equals negative 52/3, I could divide both sides by negative 52/3, or equivalently multiply both sides by negative 3 over 52, and I get x equals 1. So it actually worked out okay in spite of what we thought might happen. So to find y, I'll back substitute. There are three choices where I can plug in. I can plug into either of the first two equations, but the easiest place to find y is in that step 1 equation where I have y by itself. So I take y equals 4/3 minus 4/3 x. I put 1 in place of the x, and I get y equals 4/3 minus 4/3, which is 0, and my solution is the 0.10. We can easily check that by plugging into both of the original equations. That's a very easy one to check, because as soon as you have a 0, that makes it really nice. I'm not going to take time doing that because we've done it so much on the last lecture, but we will do it on our elimination problems. Okay, so my point is that was a really bad problem, but it's not going to be so bad. Let's ignore it for a minute. It's going to come back. So everything on this slide is going to come back in just a second. But before we do that, how would you solve x minus 3 equals 4? Well, most of you think that's very easy, and it is. We just add 3 to both sides. Why am I allowed to add 3 to both sides? Because adding the same thing to both sides doesn't change the solution. That's one of my properties of equality. Technically, it's the additive property of equality. You don't need to know that, but just for those that actually think it's kind of cool. Now, I know that 1 plus 2 is equal to 3. What if, for some bizarre reason, don't worry about why, but what if I wanted to add 1 plus 2 on one side of the equation and add 3 to the other side of the equation? Can I do that? Yeah, I can do that. It's still just adding the same thing to both sides. If 1 plus 2 is equal to 3, I could take 1 plus 2 and add it on the left, and I could take 3 and add it on the right, and it's exactly the same thing because I'm still adding the same thing to both sides. It's just in a little bit of a different form. So don't worry about why, just worry about whether I can do that. And I can because I'm adding the same thing to both sides, even if the form is different. Okay, so let's come back and look at this problem again. I have 4x plus 3y equals 4, and negative 4x plus 10y equals negative 4. What if I wanted to add the negative 4x plus 10y on the left-hand side of the top equation and added negative 4 to the right-hand side of the top equation? Am I allowed to do that? Look at it really closely. If I take the negative 4x plus 10y and add it on the left-hand side of the top, and negative 4 and add it on the right-hand side of the top, yes, I'm allowed to do that because I'm still adding the same thing to both sides. And when I do that, look at what happens to the x's. I have 4x minus 4x, my x's cancel. 3y plus 10y gives me 13y, and my 4 minus 4 gives me 0. That just gives me 13y equals 0. Divide both sides by 13, and I get y equals 0. Now, as soon as I have y, I can plug it into either equation to find x. I get 4x equals 4, so x equals 1. So I just got my solution 1, 0. Now compare what I just did in this left-hand column to what I did on the right 2/3 of the page, and look how much easier that is. This is a problem that is very, very easy to solve using elimination, but it's a pain in the butt to solve using substitution. Now, some are going to be easier one way rather than another, and we'll talk about that at the end of the lecture, but just so that you can kind of see why you might want to use something other than substitution, because there are some problems where substitution's a pain, but elimination's really quite beautiful. Then we'll do the next video. We'll start doing some more examples.